Okay, I will just start talking now. I hope you can all hear me well. If there are any comments or raised hands, I do not see them right now with my presentation, so maybe just speak up if you want to say something. But yes, welcome to today's ALASCA Tech-Talk. It's ALASCA Tech-Talk number 28. I think everyone here knows me already. My name is Ariane. I am ALASCA's community manager. And before we dive into the Tech Talk or the agenda, just very briefly, the ALASCA Tech Talks is a monthly recurring online meeting hosted by ALASCA, where we are developing open source technologies for building and running cloud infrastructures, and strengthening digital sovereignty. And we also really enjoy talking about innovative ideas, technologies, developments in this area. So this is why we are coming together once a month here, to talk. Please note that this session will be recorded. I think you got the alert when you entered, because we will be uploading this to YouTube later on, so that you can rewatch and share, and so that people who cannot be here today have a chance to see this as well. So for the agenda today, we will dive right into today's Tech Talk, and we will have time for discussion afterwards. Then we have some news and events, and we will be announcing the next ALASCA Tech Talk as always. So today, I'm very happy to welcome Max Hamati from Tech. He's working as a system engineer, and he's picking up a topic that we have discussed, I believe, maybe even exactly 1 year ago. I'm not sure. He will be talking about uStack. That's GitOps-based Lifecyle Management for OpenStack Environments with Yaook, which is an ALASCA project, revisited. And that's my brief introduction, and I will hand the stage over to you, Max. Let me give you the presentation rights. And I believe now you can start.
Okay, then let's just dive in. So, as Ariane said, this is a follow-up of a tech talk held by Matthias Haag, my colleague, about a year ago. And content is basically what has changed since then. And just a few words about me. I'm co-founder of the Tech AG, and since late summer, fall of 2024, I mainly work on the development of uStack, and I'm a free and open source software enthusiast. That is free software as in freedom, not free of charge. And I'm also a vintage computing hobbyist, and that's why you see maybe some old computers in some of the slides. So, for example, here, this nice tape machine from a very old computer. So let's start with the technology stack overview. We have at the bottom, we have uMetal, which is for bare metal provisioning of servers. And at its core, uses MetalCube for bootstrapping the hardware, the servers. And this is done via Redfish or Pixie Boot. Then for managing the clusters, we use Cluster API. And this means we have one Kubernetes cluster, which is for managing other workload Kubernetes clusters, one or many clusters. So everything you want to configure setting up a new server is done via resources in the management cluster, and then via Cluster API, this is then just executed. So new servers get provisioned and installed and will join the cluster. And this is GitOps based, so every change will be in a Git repository. And on top of that, on top of the Kubernetes on bare metal, there is uStack, basically the main topic of this talk, which is the installer for OpenStack utilizing Yaook, and can consider the core components Yaook for OpenStack and RockSafe for storage. And this is also GitOps based. And then there's uGarden, which is Kubernetes on OpenStack, again with Cluster API. So again, you will have a management cluster where you then manage the workload clusters, and OpenStack VMs are then used as nodes. I think this is a common pattern. What's interesting about this is uGarden is using Kamaji for the control plane. That means that the control plane nodes of the workload clusters are not Kubernetes nodes in the classical sense, but they are pods in the management cluster. And this is a bit of a specialty here. And then there's UView, last but not least, Web UI for the whole stack. Then let's dive into uStack and have a quick overview of uStack. At the core, of course, there's OpenStack using Yaook, and we want to ship the best practice configuration by default. So if you set up a new OpenStack cluster, then you should have a well-configured cluster right from the start, and is all based on Argo CD applications for GitOps, which means the single components are packaged in Argo CD application, which is a resource type of Argo CD. And those again are packaged in Helm charts, and there's one main Helm chart and then several helper main charts, Helm charts. And this whole concept uses the so-called app of apps pattern. So there's one main entry Argo CD application, which then installs other applications as they are configured. And optionally, it can set up a Ceph cluster using Rook. And additionally, there are some other components which can also be installed. Just to name a few, there's Ingress Nginx, there's Thread Manager, Metal LB, Local Path Provisioner, just to name a few. So the goal is that if you set up an OpenStack cluster using uStack, then the goal is that you have a ready-to-use cluster at the end. And now for the milestones, what we achieved compared to the last talk. So first milestone is the integration of RookSafe. So just to catch up, Ceph is a clustered storage solution using Kubernetes. So Ceph itself is a clustered storage solution, and Rook is for setting up the storage cluster via Kubernetes. And the idea is that we use RookSafe to provide storage for OpenStack components, namely Glance for virtual machine images and Cinder for volumes for virtual machines. But also it will provide storage classes for Kubernetes. So it can also be used for storing data for Kubernetes services. There are alternatives to this, which we also used, especially in the beginning when we when we set up development or test environments. So for a quick setup, we used NFS subdirectory external provisioner, which basically provides storage on an NFS share. Well, with all the benefits and negatives that come with NFS. Possibly there are also other alternatives, but we didn't try them out. Something like ClusterFS, MinIO, EFS, etc. So for the goals of this integration were that we integrate, for one, the Rook operator in the install method, and also set up the Ceph cluster to use with OpenStack out of the box. And this is what we achieved. And yeah, we set it up by default to set up the Ceph cluster and have it used in OpenStack. But we also make it optional, which means we support not having a Ceph cluster at all, or bring your own Ceph cluster scenarios. This is, by the way, the picture. That's the official Rook mascot. What were the challenges in the integration? Well, for one, the Ceph cluster and the consumers can potentially be in different namespaces. But the problem is, if you have the consumer in one namespace, I mean, the consumers require credentials, client credentials, to access the storage, the Ceph cluster, and this is not directly supported by Rook, so it will only create the credentials inside a namespace where the cluster lives. And interestingly enough, Rook will automatically provide a cluster-wide Kubernetes storage, but for normal consumers, it's confined to one namespace. So we had to solve this by adding another operator, which is the cluster secret operator. Also small open source project, which we also contributed to. And another challenge was determine what are the best default settings for our scenarios. For example, by default, Ceph will communicate over the Kubernetes network, the cluster network, and we changed that to default to host networking, just so that you don't have so much load on the Kubernetes cluster network. And another thing we learned is that we had to disable the mon failover mechanism, which basically means that the mon hosts, which are one of the control plane parts of Ceph cluster, they are pinned to specific nodes. And the problem we had several times with mon failover enabled was if you are in maintenance mode and then something happens to So you upgrade one node and another node encounters an issue, it will try to move to the rest of the mon servers, which then could die of overload. And also challenge was to still keep flexibility in the configuration options. So have a good default, but also give the possibility to change the configuration whatever you want. So if you want to adjust it to your needs. And another challenge, especially in the beginning, was to have a testing and development environment suited for self-development. The next milestone we achieved was the integration of Octavia load balancer. And Octavia is a OpenStack project. It is a OpenStack component which offers layer 2, layer 3, and layer 7 load balancing. And as an OpenStack component, it integrates nicely into the OpenStack API. So Yaook already ships a variety of OpenStack components, and this was just adding another component. So we thought, how hard could it be? How hard can it possibly be? Well, it turned out Octavia is a real beast, and let's dive into the architecture of Octavia a little bit. So this is Octavia Amphora, the default configuration, or the way that Octavia project is meant to be used. And the load balancing itself is handled by VMs in the OpenStack cluster, the so-called Amphora VMs. And there are several services accompanying. So there's this worker service which spawns the Amphora VMs when you create a load balancer through the OpenStack API. And then there's the health manager service, which receives heartbeats from the Amphora VMs from time to time. And this is very important because with that, the Amphora VMs can tell the system it's still there, it's still active. So if some of the heartbeats don't make it through in a certain amount of time, then the load balancer, the Amphora VM, is considered failed and will be replaced. And there's also this housekeeping manager which will clean up Amphora VMs which are not used anymore. And Amphora lifecycle is managed by switching to a different Amphora VM, which is called failover. So, for example, if you have a new OS update for the Amphora VM image, then you just start a new virtual machine, or Octavia will start a new virtual machine, and you provide a new image and then start the machine, and then just at some point switch over to the new virtual machine. And this is also done if the active Amphora VM has an error or something like that. So the main challenges, just to set the stage, the Amphora VMs, they have inside a HA proxy service running for providing the actual load balancing logic. And there's also the possibility to have active standby, which means for each load balanced service, there will be 2 Amphora VMs spawned at any time. So there's one which is actively doing the load balancing and one just as a standby. So you can really switch over without having a real interruption in the service. And they have to connect to the health manager service, which is via the so-called load balancer network. It is also called load balancer management network in the documentation somewhere. Basically, this is a separate network where the services and the M4 VMs communicate with each other. Initially, it was implemented as additional provider network, which means really physical network. And that means that at least the compute nodes and the nodes where the health manager service are running have to be connected to that network, which requires additional setup of network, maybe network hardware, and it also requires a large enough IP address pool. And then at some point we became aware of how Color Ansible was doing it, and they were implementing it as a overlay network in OpenStack, and that has the benefit that you don't need the extra hardware or physical setup, and then expose the health manager service to that network using OVN ports on the relevant nodes. And this is then controlled via additional labels which were introduced into Yaook. And this required some effort in the implementation. And another thing which is a challenge was just solved a few days ago. The Octavia service, other than the remaining OpenStack services, doesn't support on-the-fly upgrades, so it will require a maintenance window to do release upgrades of Octavia. So another milestone were additional components we added. For example, we for providing local storage to Kubernetes nodes, we added the local path provisioner, and we are also planning to integrate local LVM provisioner, which is a fork of the local path provisioner with additional capabilities regarding logical volume manager. And we want to provide SCS compliant cloud out of the box. Therefore, we integrated OpenStack Flavor Manager and OpenStack Image Manager. So after Yaook is done setting up the OpenStack cluster and the OpenStack cluster is ready, we will have but optionally running those two managers, and the Flavor Manager will then install all SCS flavors, and the Image Manager will download and provide some standard images. And also we integrated MetalLB for managing load balance services inside Kubernetes, and yeah, that's also something we use from time to time. But as that, all these components are purely optional and can be turned on or turned off. Another milestone are custom Yaook operator builds. So we noticed that sometimes hand charts, upstream Yaook hand charts of stable releases would disappear after a time. And we just wanted to retain those Helm charts and don't lose the stable Helm charts we use, which is really a problem if you have a production cluster and have to do some maintenance and then just breaks just because the Helm charts are missing. And also wanted to provide a custom operator image build, which allows us patching some things. So if we use some stable release and we know it's achieved all, it's stable and it's working, just to fix a tiny bit, then we can backport a patch and then just release that without risking breaking anything when upgrading to a new release. And also this offers us the ability to make custom feature builds. So if we want to test a new feature or something in a test environment, we can also use that. And then we also want to provide custom Helm charts referencing the respective operator image, be it a patched one or with new features. And then we decide to move to a formalized workflow. So this is here a simplified example of how it works. So basically the reddish lines are representing upstream Yaook operator, Git repository, and then we have this Uhuru CI branch, which is designed to be merged in with the upstream Yaook operator repository, and it contains CI pipeline definitions. So let's say we have here a stable release in the middle, upstream stable release, then we can just make an unmodified release with our own Helm repository, our own container registry. And if we want, for example, to backport a fix or a feature or whatever, then we can cherry pick that on that branch and make another release. And we also have a few other cases, but let's not get too much into detail. So then last but not least, there's the developer experience tooling. So the idea is to bundle many developer tasks you have into one tool and make the life of the developer easier. And one feature is just to set up a test and development environment. This is designed to allocate a Kubernetes cluster using your Garden, and then deploy the current development version or test version what you want. And this as simply as just call it use the dev system create, and it will give a bit of output, and you have to wait probably a bit, and then you can use your cluster. It can use the default configuration, but also you can supply custom configurations via command line parameter. And it also can run tests and linting. For now, that's limited to local tests, which means it's code formatting, code linting, and call it, for example, uStack CI check, and then it will run the code linting on the repository checkout. And then we also have the possibility to debug Helm charts, because we noticed in using Argo CD, and there's a problem in with Helm templating, then it can be hard to debug without any help. So what Argo CD does internally, it will call Helm template and generate all the manifests and then just apply that to the cluster. And if some error occurs, the message, if you see the message at all, the message will reference the generated manifests, but you don't see those manifests anywhere. So we introduced this uStack template that generates all the manifests for a given configuration, and then you can at least look at the error message and have a hint what's wrong. And just a few other examples. Manage the configuration of the OpenStack flavor manager with OpenStack flavor update. You can just put a new configuration into the cluster, and the same goes for the image manager. So for example, if you have disabled at the beginning, you can just enable it, add more flavors images. And well, then let's come to the conclusion. So for the roadmap for what we are currently doing, we want to improve the automation of release management and versioning. Basically, until a few weeks ago, this was all manual tasks, and we at least have for the versioning, we have some degree of automation. We are now investigating how to do release note handling the best. And our idea is the best would be to automate it with some kind of semantic versioning. Then another thing is we have to improve the documentation. It's currently sadly lacking a bit behind. And what we also are currently implementing is that we want to have an integration test and really test the resulting OpenStack cluster, especially the basic functionality. And what we already achieved is that we have the ability to set up Kubernetes cluster, set up the OpenStack, and then have a few checkpoints when everything is ready and set up all defaults, set up networking, and so on and so forth. And basically, it's the last step is missing, testing the functionality, basic functionality of the OpenStack cluster. And for that, we want to utilize the SES workload generator. And well, eventually we want to also automatically test a few Yaook upstream branches. So maybe at least a stable branch, or some feature branches which are interesting. And then also we're hoping that we can give feedback to upstream in an automated way. And we're also currently adding observability and monitoring stack, and also customer lifecycle management. So that's one part which is currently missing in the standard OpenStack is if you are a cloud provider and you want to partition your OpenStack cluster, how do you handle onboarding, offboarding of customers, billing, and so on and so forth. Well, then a few lessons learned while we implemented most of the logic in using Helm templating, and that proved a bit hard. For one, the templating language is hard to read and also hard to remember, and there are also cases where there's unexpected behavior. For example, the definition of if some value is unset, then make it default is very hard because there's no proper, very sane definition of what is empty or unset. And another problem is that it's inherently decoupled from the cluster. So with Helm templating, it's basically like having business logic in the client instead of the server. So you cannot reason about the state of the cluster, for example. And then Argo City has its limitations as well. So as I said before, the Helm templating, error handling is a bit of a problem, but also we have this so-called autosync enabled, which is required because of interdependencies between the components. So if you don't have autosync, one would block the components block each other in the deployment, and you would have manually sync it all from time to time during the deployment, and that's not feasible. Therefore, this is required during deployment, and also Argo CD itself has to be configured in a certain way to handle the uStack installation. For example, some of the components which are installed do not work well with the resource tracking functionality of Argo CD. So it needs some tweaking that it works with all the components. So what are the plans for the future? So at some point, we definitely want to move the logic from Helm templating to a real programming language, which means basically implementing our own operator, and that would massively reduce the dependency to not only Helm, but also to Argo CD. Would allow us reasoning about the state of the cluster and also lowers the maintenance burden. Well, and another plan is to have a logo, which is currently missing. Well, and that's basically it. So, thank you. Are there questions?
Yes, thank you so much, Max. There has been excitement in the chat about the battle chess screenshot. That's a good thing. But yes, if there are questions, just speak up or write them in the chat. Both is fine.
Yeah, hi. I might have a question. First of all, thank you very much. This seems to be really involved to get all these different bits and pieces to work together. And yeah, my respect definitely for your work, and thanks for your presentation. I tripped a bit over this SCS workload generator. I don't seem to have heard about this yet. Can you say what this is about, please?
So what it does is basically set up a new project in OpenStack, set up users, create a few virtual machines, and I think that's basically it. And with that, you already have, I think, 90% of the OpenStack functionally tested.
Okay, got it. Thank you.
You can find it. You can find it in the. Sorry.
Yeah, exactly. That was my question. Where can I find it?
And you can find it in the Sovereign Cloud Stack institution in GitHub.
Thanks.
Okay, are there other questions? Max has just dropped the link to the chat. Thank you. If there are no other questions, Max, you shared your contact info on your last slide, so I'm sure if anyone wants to know something afterwards, they can reach out to you. All right, so then thank you again. I would move over to some community news.
Thanks for the stage.
Yeah, always, always happy to have you. I will get the presentation rights back and share my screen. Oh, back to the beginning. Okay. Let me skip here. Okay, so yes, news and events from our side. Just the reminder that the registration for the Alaska Summit is open now. I think everyone here in this round has heard of the event, I hope. And I hope everyone has registered too, but no, if you want to join, you can totally do this. It helps us also for planning, so if you want to be there, you can please register for free. Everything is on our website as always. There are construction works in the apartment above me. I hope this isn't too disturbing. Other than that, maybe some news. There has been an open letter written by the OSBA to Claudia Plattner from the BSE. There have been discussions about the achievability of digital sovereignty for Europe and Germany. And we as Alaska have also signed this letter. If you are on LinkedIn, you probably have come across this. And we really appreciate the quick reaction from the OSBA. There has been a reply from Claudia Plattner already. And from what I heard, it seems that there's like definitely agreement and maybe also some exchange in the future. I don't know if anyone wants to add something to this topic. Just always speak up because right now I cannot see the chat, but yeah, that has something that's been going on this week. Otherwise, due to the holiday and vacation time, there wasn't much going on. But we did have our annual meeting on August 13th, which was really nice. We talked a lot about the past months and what's going to happen in the future. We also just published the Alaska Community Digest for the second quarter a few days ago, which gives you a report on everything that's been going on, also insights from our open source projects. Also a hackathon report, so you can look that up and read if you want to. Then there is one thing that I haven't included in the slides. Alaska has a new colleague. We have hired another person with our Focus funding project. It's Friedrich Zahn, and I think he's here and is happy to introduce himself.
Yeah, hello everyone, I'm Friedrich. I'm happy to join Alaska in the Focus team now. I started like 3 weeks ago. A few words about myself. I studied in computer science in Dresden, but now I'm living in Leipzig. In the meantime, I developed Kubernetes as a service product for an Austrian company. I did a fellowship with the Ministry of Foreign Affairs in Berlin, focused on user-centric product development of digital services and user research. And my last job was with the city of Leipzig, connecting smart city projects with the open data services of the city of Leipzig. And yeah, now I'm very happy to join Alaska and doing free and open source software as my main piece of work and not just an afterthought. So yeah, very happy to be here.
Yes, welcome again. Yeah, Helena also just wrote she's happy, or I think the whole focus team is happy that you are on board. And yeah, let me quickly jump back. Also, Helena, thank you for dropping all the links in the chat on the stuff that I've just been talking about. So other events or news from the community? I still have some events from the SCS and OSBA. I think Felix is here. Is there anything you want to share?
He said that he can't speak.
Okay, that's fine. Okay, yeah, most of you probably know about those events anyway, and you can just look that up. Are there any other news or events anyone would like to share? If not, we can wrap this up. Yeah, you know everything about the Tech Talks. We are fully booked for 2025. So if you have any topics for next year, always reach out and make suggestions. Just write us an email. But yeah, we have a nice lineup for the last few months of this year. Also for September, of course. So in 1 month, we are happy to welcome Steve Starke and Silvio Ankermann from Cloud & Key Technologies, and they will be talking about Tarook. Tarook is one of ALASCA's open source projects. It was split out of Yaook, and it's a holistic lifecycle management of Kubernetes clusters on bare metal or OpenStack, and they will give us an introduction to this project. So this is very interesting, I think. And yeah, I guess that's it from our side. Thank you everyone for joining. Thank you again, Max, so much for being here and for taking the time to present uStack to us. And I wish everyone a beautiful weekend and hope to see you next time.